This video contains 3 examples of different types of word problems. Every time you create a word problem, the first thing you need to do is define your variables. So this first problem is talking about two numbers. So let's let x represent the larger of the two numbers. And we'll let y represent the other number. So the next thing that we're going to do is create the equations. Now we're going to go and look at the pieces of the question and put those words into numbers. So the first part says two numbers have a difference of 2. So that means the larger number, take away the smaller number, is equal to 2. The second sentence says 3 times the larger minus 2 times the smaller is 9. So 3 times the larger, that's x, minus 2 times the smaller, that's y, is going to be equal to 9. Now I've got my two equations. How am I going to solve this? Well, probably what I would do is use substitution. So I'm going to rearrange x here to get a third relationship. And then I'm going to substitute my third relationship equation into my second. So 3 times 2 plus y minus 2 times y equals 9. Now I can simplify and solve in order to get y equals 3. So now that I've got my value for 3, I'm going to substitute y equals 3 back in to my equation number 3. So now I've got x equals 2 plus 3, which means that x equals 5. So therefore, the two numbers are 3 and 5. Let's do a second example here. There we go. So this is about money. A wallet contains $4.55 in dimes and quarters. That's going to give us our two variables that we're going to use. So let D represent the number of dimes, and we'll let Q represent the number of quarters. So that first sentence tells me that a wallet contains $4.55 in dimes and quarters. So that's the amount of money. So I know that it's 10 cents times the number of dimes that I have, plus 25 cents times the number of quarters that I have, and that's going to equal my total amount of money that I have. And then my next equation is going to be how many. So I've got the number of dimes plus the number of quarters has to equal 23, and that's my second equation. Now this one I'm going to try solving by elimination, because I see some decimals. I kind of like to get rid of the decimals. So what I'm going to do is I'm going to multiply this first equation by 100, and I'm going to multiply the second equation by 10. So I've got 10d plus 25q equals 455. And then here I would have 10d plus 10q equals 230. So now I've got two new equations. And I think the first time I did this video, I used substitution. Either way will work. And now you can see a different method. So now you should notice that my coefficient in front of d is the same. So now I'm going to subtract those two equations to eliminate my variable. And I'm going to be left over with 15q equals 225, which results in Q equals 15. So now I have my value for Q, and now I'm going to substitute Q equals 15 back into my second equation. D plus Q, which I think is 15, equals 23. And that's going to leave me with D equals 8. So therefore, there are 8 dimes and 15 quarters. Example 3. A berry mixture costs $5 per kilogram. It consists of strawberries priced at $4 per kilogram and raspberries priced at $6.50 a kilogram. If a pie is made using 600 grams of the mixture, what is the mass of strawberries and raspberries in the pie? So first thing that we want to do is set up some variables. So let's let R represent the number of kilograms of raspberries. And let's let T represent the number of kilograms of strawberries. And then we can set up a chart to do our equations. So we've got our amount of berries, and we've got the cost of the berries. Those are going to represent our two equations. So we've got raspberries, strawberries, and then we've got our mix. So raspberries, that's our variable. So we said R for the amount, T for strawberries, and then the total amount that we have is 0.6 kilograms. Now the cost of the berries, for the raspberries, it is $6.50 times R, and for the strawberries, it's 4 times T. Now the mixture is 5 times the amount of the mixture. So now we can set up our two equations. So we've got R plus T equals 0.6, and then we've got 6.5 R, I'm going to drop the 0 for now in the equation, plus 4T equals 3. So I think that I'm going to solve this using substitution. So I'm going to rearrange for T by moving R over. So I've got 0.6 minus R. And let's label my equations like I did before. So 1, 2, and then my third relationship. So now I'm going to sub 3 into 2. So I've got 6.5 R, that stays the same, plus 4 times 0.6 minus R equals 0. So 6.5 R plus 2.4 minus 4R equals 3. And now I can simplify and rearrange to get the variables on one side and the numbers on the other side. And I should get 2.5R equals 0.6. And that means that R equals 0.24. So now I've got my relationship, or my amount of raspberries in the mixture. So I'm going to sub that value into my equation 3, which is really my equation for T, 0.6 minus 0.24, and that's going to give me my amount of strawberries. So therefore, there are 0.24 kilograms of raspberries and there are 0.36 kilograms of strawberries. Strawberries.